Yeah, Naveen, you can start about the introduction about
Sure.
after the plot. Yes,
Hope I am audible to all clearly.
yes. Yes.
I welcome you all to this webinar organized by the construction leaders. It is my honor to introduce our distinguished speaker, Mr. BP Karamchandani Garu, the founder and CEO of MV.com. He is having a strong educational background in civil engineering. He did his diploma from KJ Somaya Polytechnic and BE in civil engineering from VJTI Victoria Jubilee Technical Institute. Early in his career, he played a pivotal role in executing underground drainage works for the Maharashtra Water Supply Board. Over the years, with a continuous quest for knowledge, he evolved his expertise and created the groundbreaking MV-DAD software, and his mission is clear that to build stable and economical structures that prioritize the safety of human lives. We are fortunate to have you here, sir. Welcome to the session, and over to you, sir.
Thank you. Thank you for your kind words. And thank you, Mr. Rajkumar, for arranging the webinar.
Welcome.
Yeah. Is this screen visible?
Yes,
Yes,
sir.
sir.
Yes. Basic introduction, mvlet.com. It's for the stable structure solutions. Motivators, Sir M. Viswasaraya, India's greatest civil engineer, MV. My dad, Professor P.K. Karamchandani, DAD. Hence, the name of the software is MV-DED. As it is online, hence it is mvdet.com. Till date, we have conducted 32 webinars cum seminars across the India. The map is on your screen. And we have provided the exclusive project login access for the civil engineering students so that they can log in and educate themselves. In technical terms, MV-DED, M stands for moment, V for shear, D for deflection, A for analysis, D for design. Hence it is MV-DED. It's a cloud-based RC building, earthquake-resistant structural design software as per the IS code 456, 1893 and 13920. It is free for education purpose. Features. It's a 5 in 1. One is analysis, second is the design, third is drawing, fourth is calculation, fifth is bill of quantities. Under the analysis, two ways. One is the gravity loads, that means vertical loads. Second is the seismic loads, that means lateral loads. Under the gravity loads, coefficient method, fixed end moment, 2D and 3D frame analysis, and final is the finite element analysis. Under seismic loads, two methods, static equivalent coefficient method and dynamic response spectrum method. Under the dynamic response spectrum method, three sub-methods are there. Absolute sum method, square root of sum of squares, complete quadratic combination to check the structure's stability, drift, and displacement by P delta method, whether the structure is stable or not. Design. Generally, we provide the sectional sizes to the software and the software carry out the analysis. But in our case, it's a totally automatic. By reiterating each and every element, it will design the most economical section. That is footing, column, R beam, that is flange beams, L beam and T beam, slab one way, two way. It's economical beam design on the basis of bending moment at the face of the columns. Generally, softwares provide the value of the bending moment at the center of the column. But by way of finite element analysis, we are calculating the bending moment analysis at the face of the column, which I will show you in the results and how this software becomes the economical. Third is drawing. We provide the plan, elevation, sectional elevation, reinforcement detail drawing of each and every element, shear force diagram, bending moment diagram, center of gravity, center of mass, torsion floor-wise, displacement, drift. For the earthquake analysis, all the drawings are displayed for the better understanding. Calculation. Detailed step-by-step calculation for educational purpose for each and every element. 2D method, 3D method, finite element analysis, everything is displayed as we are calculating during our education time, so that user can understand how the results arrived. Fifth is the bill of quantity, which we require at the time of execution. Cement, element-wise, grade-wise, module-wise, floor-wise. Similar way, steel reinforcement, dia-wise also we will provide, so that builder can place the order as per the site conditions requirement. Benefit. Benefits, most important, we require nothing. Nothing means neither trained professional, nor software, nor hardware. We require nothing. Generally, we require draftman for drawing, and then professional engineer for analysis, design, detailed drawing, and bill of quantities. Whereas we don't require this. Tools, that means software, operating software, drawing software, analysis software, design software, RC detailed drawing software, bill of quantity software. All these we don't require. And hardware, specific hardware not required. We require only any mobile phone with internet connected facility, that means smartphone with internet connection. Freedom. From COVID period, we came to know about the work from home or work from anywhere. But we are working on this platform since last 13 years. It's a cloud-based. You can work from anywhere on smart mobile. Multi-access, number of users can access at the same time. Multi-users, multi-locations. It's a green revolution, environment friendly, paperless. Modeling, it's purely automatic, which I will show you. Then it is safe, earthquake resistant, stable structure to save the precious human life. That is our aim, so that each and every engineer should be aware of the structural engineering codes and bylaws. Its availability. It's available 24/7, 365 days, so that It can save your precious time and you can work on number of projects from number of locations. Reports, transparent results along with entered data in MS Excel and graphic and PDF. Cost, save on expensive software and computer hardware. That means we don't require any capital cost. Data. For the new project, we require only 12 data. That also from the drop-down box. What we require? The city where the project is located, so that seismic zone and seismic factor will be taken care by the software. And the basic requirement of this project, number of floors, basement height if it is available, ground floor height, floor to floor height, that is variable height for variable floors, that provision is there. Plinth height above ground level, foundation depth below ground level. Then building type, whether it is residential, commercial, school or industrial. So accordingly, SIDL and SILL as per the IS code 875 will be taken care. Soil type, soft, medium, soft rock, hard rock, which we require for the seismic coefficient purpose. Steel grade, Fe415 or Fe500. Concrete grade from M15 to M40, the provision is there. All this data to be selected from the drop-down box from the bearing capacity of soil to be entered by the user, which is variable for each and every project. We require the centerline plan with column location. That means slabs, coordinates, slab dimensions. Similar way, column location, where the column is situated. And other option is you provide the slab data in Excel format. That means only the slab number, X coordinate, Y coordinate, span in X direction, span in Y direction. That I will show you while creating the new project. And for the column, only the location where the column is situated. That means we don't require any dimensions, X coordinate and Y coordinate. Modeling. If we compare with the other softwares, modeling procedure is for slab, beam, column, and earthquake. They require various data from the user for each and every element. Whereas we require for slabs, length and width. We don't require the third dimension depth, that we will assume, and by a reiteration method, we will design. Similar way, beam, we don't require anything. Column, we don't require anything. For earthquake, we don't require anything. If we compare with the professional person, for other software, you have to learn each and every software, even though you are the engineer, which is time consuming, tedious, and it is repetition to make the model safe. In our case, we don't require anything, it's purely automatic. Modeling procedure of other softwares is when we have to create the project, create the grid, then create the slabs, assign the size, width, depth, length, assign the loads, dead load, live load, assign end conditions, simply supported, continuous, cantilever, assign the way, whether it is one way or two way, corners free or corners restrained, assign the grade, concrete grade, and steel. Similar way for the beams and columns, and copy on the rest of the floors. For earthquake, they require response factor, importance factor, assign the SA by G, assign seismic zone, assign seismic factor, We don't require anything, just the location where the project is situated. Then they have to run the analysis. That means as per the sectional sizes, analysis will be carried out by the software. If it fails, then you have to repeat the full procedure from 0.3 to 0.7 so that the structure should be safe. What I observed, to avoid this repetition process, engineers select the oversized element sizes. In our case, it's by reiteration method, we design the economical section. Modeling full process requires time, professional experience, structural engineer, and concentration. It's the solution, immuday.com. It's purely auto modeling. Tutorials are available on our homepage. We have carried out the webinar for the BMTC, PC, Building Material and Technology Promotion Council, under the Ministry of Housing and Urban Affairs, Government of India, New Delhi. 2 times we have conducted the webinar, and third we are going to conduct on the 8th of February. And these are the tutorials for the new project and this for the full project. If you have any doubt, any query, all these tutorials are available to satisfy your questions. Now we are coming to we will create one new project and see how much time it requires to carry out to create the new project. We write the name construction leaders CL, password CL, reconfirm password CL. Next page. As we are situated in Telangana, we will select the Telangana. Under the Telangana, Hyderabad, seismic zone and seismic vector. If any city which is not in this drop-down box, you have the facility to go to the India, other district, other cities, seismic zone 2, 3, 4, 5, and accordingly seismic vector will be taken care. And for that, you have the map of India from the seismic zones of India. Seismic zone 2, seismic zone 3, seismic zone 4, and seismic zone 5. From this map, you can select the seismic zone and accordingly seismic factor will be taken care. But for our demo purpose, we are considering Telangana, Hyderabad. All these options are available: commercial, hotel, industrial, office, residential, and school. We are considering residential for demo purpose. Meters. As per IS code 1893, we are supposed to design up to the 40-meter height, hence up to 13 floors. This software will take care. For demo purpose, we are considering 3. It's a variable height facility is there. For ground floor, 0 to 1, we will consider 3.5 meter height. And for rest of the floors, we will consider 3 meter height. Next page. As we have selected residential building, as per IS code 875, these SIDLL and SILL By default, we got the values. But we give the facility to the user. He can select higher values, but he cannot select lower than the suggested value. So all these options available. For economical purpose, we will select as per the IS code 875. But for as per the site condition, you have the liberty. You can select the higher values also. Loads on the beam, generally it's walls, external wall, floor to floor height, both side plaster, we will consider 0.23. And for internal wall, we will consider 0.15. And for the parapet, terrace, we will consider 0.23. And variable height, we are considering 0.9 meter height. Plinth height above ground level. As per the site situation, you can select, we are considering 0.6. Foundation depth, again, as per the site situation, you have the number of values. We are selecting soil type, which we require for the earthquake analysis. We are considering hard, as we are in the Hyderabad site. Bearing capacity of soil, this data only to be entered as per the site conditions and site soil report test. We are considering 300 kilonewtons per meter square. Grade of concrete for demo purpose M20 and steel A415. All this we are designing on the basis of limited state method as per IS code 456 and IS code 1893. Only this data we require from the user for the particular project. Now we require the plan, which generally provided by the architect or the builder. We have the two options. Is this screen visible? Excel format. Now is it available, visible? Excel format sheet. These are the slab data in Excel format, X coordinate and Y coordinate, span in X direction, span in Y direction. 18 slabs, all these data in Excel format. We will upload this Excel format sheet. Choose the file. We are selecting slab data. Upload. Next. As we selected the data in Excel format, so we will check this box and finish. Till now, we have entered these following data. Project name is CL. Construction leaders. Building type is residential. Unit meter. Number of stories 3. We have kept the height for 0 to 1, 3.5 meter. For rest of the floor, it is 3 meters. SIDL and SILL as per the IS code 875, 3 and 1.5 for terrace, and for rest of the floor, it's 1.5 and 1.5. External wall 0.23, internal wall 0.15, parapet wall 0.23 for the height of 0.9 meter. Project is situated at Telangana, district Hyderabad, city Hyderabad. Hence, the seismic factor is 0.1. Concrete grade M20 Fe415. Just we will finish this. If any data is not as per the requirement, we have the choice to edit that. Otherwise, directly we can proceed. The data which we have entered in Excel format, that is converted in the graphical format. S1 to S18. Coordinates are there. All the slabs are in one-way direction. That means we have not taken any data from the user. Another option is on-off canvas editor. We can create the slabs on the particular floor. Just by double click, draw the diagonal. Generally, to draw the square or rectangle, we have to draw all the 4 lines. But to save the time, you draw the diagonal, a square or rectangle will be drawn. Now we got the coordinate 0, 0 in this box, dimensions 3.6 and 3.4. We can edit that. We'll make it 3 meters span in X direction and 3.65 meters span in Y direction. And accordingly, this slab sizes are set. Coordinates 3 and 0. Slab in X, span in X direction, we will consider 2.3 meter, and span in Y 3.65 meters. 2 slabs we have created. That means no need to learn the particular drawing software. Even on this only, you can in this case, we will edit the Y coordinate. We will make it 1.15 meter. But at present, it is drawn on XX line. That means when Y is 0. Now we have changed it to 1.15. Immediately, it is shifted upwards. Right? 2.84 by 2.9. Now we have mirror images option. Select vertical, select in right direction, span. At what location it should be mirrored. Say 1.5.3, 8.3, 8.8. that whatever the location you will enter, it will be drawn. Again, you can draw in between and you can join that also. .14. Then we will make it 1.25. Sorry, 1.15. 1.35, 1.4, what's that? 2.85, 2.9. Even you can mirror in horizontal direction up. .15 plus 2.84. Sorry, mirror image up 5, 3.65, 3.65 plus 7, 4. Create image. That means all these options are available. You can draw, edit, delete. But for demo purpose, what we will stick up to this Excel format and we can copy on the rest of the floors. Copy from the first floor. Three, copy from the first floor. Second, even though we have drawn various slabs, but we can copy from the first floor and it will take care of it will delete the previous data and override the new data. Similar way for the floor 0. We will off the canvas. As we are working on cloud base, so periodically we have to save the data on the server so that all the data should be saved properly for the analysis purpose. Log off. As we have entered the data, only slab portion, 18 slabs are there. On second floor, 18 slabs. Previous data deleted, new data saved. 3 floor, then terrace. This is the zoom in, zoom out button. Now we will create the columns on the canvas. Just by clicking on the location, column will be created. Twice, this box will come. You have the option to select the column from to, that means from 0 to 4 floor or in between. That means variable height for irregular buildings. For demo purpose, we are considering regular building. So from bottom to top, we will consider the columns. And then shape, whether it is rectangular or a square. If it is rectangular, in YY direction or in XX direction. we will consider rectangular and YY direction. Just we have to click twice on that particular location, nothing else, as we play the game. 3, 4, 5, 6, 7, 8. We don't require any skill for creating the column. We will consider here rectangular columns, because beams from all the directions, but as per the site condition, you have the liberty to select the sectional size. Corner rectangular. We have created 16 columns. Similar way, we select the rest of the columns. These columns we have to select. (23), (24), (25), 26. We'll off the canvas and just we will check whether all the columns are created. That means 26 columns on terrace, on third floor, on second floor, on first floor, on the ground floor. Now we'll go to the beam. On the canvas, we have this auto beam generation for all the floors. Okay. Just we have to wait. Software will take care and create all the beams. That is 43 beams per floor for from 0 to 4th. That means 215 beams created within a 50 to 60 seconds. And we are not assigning any values, end conditions or support conditions. We will off the canvas and we will check whether all the beams are created. On 0, 43 beams are there. On first floor, 43 beams. Second floor, 43 beams. Third floor, 43 beams. Terrace. Only these data we require from the user, which took almost 20 to 25 minutes, not more than that, right? Now for analysis, just I will show you how this analysis will be taken care by the software. We have not assigned any values to the slabs, not to the beam, not to the column. Software will assign the end conditions, assign the way, assign the loads. Just we will check whether all the loads are assigned properly or not. First floor, flat. Previously, all slabs were in the one-way direction. No color. Now different colors are available. Color represent end conditions. If it is blue, that means slab support is simply supported. The right support is continuous. And for this green, orange, all these colors are defining the end supports conditions. That means S5, left side is simply support, right side it is continuous, whereas S6, both continuous, whereas S7, continuous on left and on right, it's simply support. As per the algorithm, it will be taken care by the software. We have taken only the dimensions X span and Y span. Now SIDL and SILL. 1.5, 1.5 for the first floor, and for the terrace, it is 3 and 1.5. For rest of the floor, it's the 1.5 and 1.5. That means user has to spare only 15 to 20 minutes to enter or create the project, and without any expertise in drawing or analysis. We have already created one project and it is available online. Project name is Demo Telangana, your district place B. Password, then login. I have given you the demo how to create the new project. Now I will give you the demo of the features of the software, what we are providing after the analysis. All the data is fetched from the server and it will be stored on your mobile or laptop, and it is very easy to view the full project. You are aware of this slab floor menu 1, 2, 3. You are aware of this zoom in, zoom out. Now this menu is provide the results of the particular selected floor, floor 1. All these results for slab dimensions, all the data available. As we have taken only the span in X and Y direction, depth is calculated and it is displayed on your screen. Similar way, slab is still scheduled. 17 number of bars, 8 mm dia at 210 mm center to center. This is the top steel. And for bottom, 25 number of bars, 8 mm dia at 170 mm center to center. That means all the results of all the slabs are visible on your plan only. Similar way, beam bending moment at the center of the column, which I will show you in the elevation. We will consider top floor terrace B1 value is 13.86, right? That means bending moment at the center of the column. As per the finite element analysis, we have calculated bending moment at the face of the column. It is 10.3. That means roughly 25 to 30% less for each and every support. That means 43 beams per floor, 215 beams for the full project, and both the ends, that means 430 end supports, we are saving 25 to 30% of the steel. That is the beauty of this software, and we are providing economical as well as stable structure. Now we will come back to the plan. Beam dimensions. Automatically beams generated. Automatically end conditions decide. Automatically their dimensions, that means sectional sizes, decided by reiteration method. Sizes for B13, sizes on hover you can see 0.2 by 0.3, and for B5 it is 0.2 by 0.23. All these data you have available on your, and whereas for the B32 the dimensions 0.2 by 0.65. As per the loading conditions, all the results are calculated. Similar way, beam steel in XX, that means beams which are in the XX direction. For visual point of view, I will show you the steel design. 2 number of bars, 10 mm dia, all these. A similar way, beams in Y-Y direction, that is steel available. Even on hover also you can value. If they are overwritten or not visible on the screen, just to take them out near the number, it will be displayed. Similar way, we'll come to the column dimension. We can see the columns in the, at the top it is 0.24 by 0.2, and at the bottom it goes on increasing as per the requirement 0.38. That means for each and every element, software takes care of the, and last is the column steel. 6 number of bars, 12 mm dia. AC provided 678 mm square. Right? That means all these results are on this menu. Now we are coming to the if you click on any element, floating menu will appear. If you click on the beam, floating in and represent the color of that particular element. Column menu is same, but where you have selected or clicked, it will show the results of that particular element. Now the loads 1.5 and 1.5, and for the terrace, it is 3 and 1.5. That means whatever data you have entered, they are visible on your screen, and your end supports also, you can understand how these end supports are governing. For B12 beam, its left is simply supported, right side is continuous. B13, 14, 15, color both continuous. B16, color is different, continuous, other simply supported. B43, it's simply supported. No need to remember, no need to cramp. Just you follow the software and it will educate you how we are executing the analysis and design. As you have seen the loads, if we click on the beam load, how the load is transferred from the slab to the beam, it will be visible in your graphic format. On any section, it's two-way, typical, right? B43, typical. That means how the load is transferred from the slab to the beam, and this area, if we calculate, that load will be transferred on any element. Similar way, if we click on the column, the same load menu, that means on column C13, load is transferred from B13 and B14, B34 and B35. If we click on C26, B27 and B43. Now we are coming to the calculation. If we select S15, calculation. This is useful for the students' education purpose. Full data calculation will be similar project we will open in the additional table. Yes. We have selected slab number S14, S15 and floor 4 at the top floor terrace. Color is yellow. This navigational bar will help you. And this is the procedure which we are following. For slab, we require the data, dead load and live load, which we got as per the IS code 875. Then floor finish and self-add, which we have to assume and calculate. Then element size, we got from the user, width and length. Now we have to assume the sectional depth, and of that section, we have to analyze shear force and bending moment. And we have to design the reinforcement. After the design, we have to check whether this assumed section is safe for shear, bending, deflection, or development. If it fails, then by reiteration method, it will take care to increase the size till it satisfies all these conditions and make the element or slab safe. And last is the bill of quantity, which we require for the execution purpose, reinforcement and cement. Now this navigation bar, slab data, as per the IS code, the clause is mentioned, simply supported, other continuous, two-way restraint, IS code, class number, conditions, page number, whether it is satisfied, and according to that, left support and right support, and conditions, coefficients. Then modification factor, LD ratio, span in X direction, span in Y direction. According to that span, modification factor, we are assuming the section 70 mm, but IS code says it should not be less than 80 mm. and cover should be minimum 20 mm. That means minimum slab thickness height should be 100 mm. So instead of 70 mm, we are assuming 80 mm plus cover, effective cover 20, total depth 100 mm. For this depth, now we will analyze the full section to calculate shear force and bending moment, and accordingly we have to design the steel. Detailed calculation is available. I will skip this because it's self-explanatory. For each and every element, calculation is in the tabular format and easy to understand. We are calculating shear and bending moment as per the coefficient method. And after that, same procedure we are repeating in the slab 2D frame analysis. Under the 2D frame analysis, that means fixed end moments we have to consider as per the formulas. Formulas are shown: WL square by 12, end conditions. Then we have got this fixed end moments, equivalent bending shear and equivalent working shear. As our is S15 and S16, that means continuous, simply supported, other continuous. That means two slabs are in the one sequence. So two slabs are calculated, and sorry, S15, now it's the S16. These values which we require for the distribution factor, left side simply supported, right side continuous. By moment distribution method, we are calculating the bending moment at the supports and maximum bending moment to provide the steel. All these values are in the tabular format, easy to understand. As per the IS code norms, three methods: max min, min max, max max, maximum of above 3. For earthquake analysis, we have bifurcated this dead load and live load separately, which we require for the 25 load conditions. So you can skip that also. Ultimately, what we got: shear force and bending moment as per all the three cases, and maximum of above values for S15 and S16. We have got the shear force and we have got the bending moment, and maximum bending moment also at the distance that is also mentioned at 1.32. As left support is simply supported, hence the value is 0. Right support is continuous, then that shear value is there, bending moment is there. And according to this, these values 0 kilonewtons per meter and 6.9, we will provide the steel. That is, up to here we have executed the analysis, and now we are doing the design. Again, as per the IS code, two-way, restrand, all these conditions, all these coefficients we have to satisfy, and accordingly we got the values and supports, penultimate supports, anterior support, and everything. Then shear value also we got. Now for the design, ultimate moment carrying capacity of the section, as we are assumed 80 mm thickness, and for that its carrying capacity is 17.66, and where is our bending moment is less than this, it's a 9.18. Hence the depth which we have selected is safe till now. Then as per the formulas, we have calculated the steel, number of conditions, spacing, all dia, everything is considered, and we are calculating the percentage of steel. Minimum required is 0.44%, but we have provided 0.48%. That means very near to requirement, hence it is economical. Secondary steel, as it is two-way, same calculation procedure. Top steel at left support, at right support because of the continuity. Then check for the shear. All this menu will help you. Check for shear, check for development length, and bill of quantities. Concrete quantity, then weight, steel weight quantity. Number of bars, that weight, that means for S15 slab, main steel is 56.9 kg. Additional steel, 40.3, total steel, 97.2 kg. And then the final is the result. Slab number, floor, two-way, grade of steel, concrete, effective cover, effective depth, dimensions, quantity, secondary steel support at midspan, main steel support at midspan, their quantity, and area-wise, weight-wise, total. That is for each and every slab, we are providing you the calculations. If you want, you can have a look on this. Any slab, you will get the values. Now, third is steel drying. Whatever we got the results in the tabular format, we are displaying in the graphic format. Left side simply supported, right side continuous, and according to that, the steel is provided, number of bars at top, at bottom. Everything is on graphic mode. Project name, floor, slab number, date. Main steel, secondary steel. Now steel design. That means the result total which we require for the particular floor. For all the slabs on that particular floor, that means floor 4 in the tabular format for execution purpose. Similar way, we'll go to the beam calculation as we have selected B34 and B35 calculation. B34, B35. Let me simply support it, other continuous. Sky blue color for beam. Again, this navigation bar, then procedure. I have shown you how the load is transferred from the slabs and how the wall load is there, self-weight. Then solution. We have to assume width and depth also for the beam. As we have not taken any data from the user, we will do the analysis by 3D method first to calculate the shear force and bending moment at the center of column, and by finite element method, we will calculate shear force and bending moment at the face of the column, which is 25 to 30% economical, roughly, which I have shown you the values. Then design, again the checking and bill of quantities. Similar way, then analysis. This is the 3D analysis, that means column will also take care to make this structure stable. Then moment distribution, bending moment, shear force, finite element analysis. This finite element analysis, to make this structure economical, it's a very lengthy procedure. Just for your reference point of view, go through it. For each and every chain, how much data to be calculated. So roughly 30 to 40 pages to make the structure economical as well as stable. Just have a overlook. Ultimately, we got the results. 16.43 at the center of the column. At the face of the column, it is 13.08. Maximum 15.17. All these values 29.56, 16.43 at the center. That means we have shown you the tabular format also and graphic format also. Similar way, shear force. Now we'll do the design. After analysis, design will be taken care. Again, same formulas, but we are designing the steel as per this bending moment at the face of the column. Now beam, whether it is T-beam, L-beam, R-beam, it will be taken care by the software as we have selected B35. Load is from the both side, hence it is designed as the T-beam. If it is B29, then it will be designed as the L-beam. Hence T-beam. Again, the T-beam formulas, calculation. Just I will skip it so that you can view it on your mobile or laptop and understand. These values are for the 25 load combination, which we have shown. For B34, whatever the values we have got, ultimate values, and for that, we will check and design the section. Shear check. We'll check the width also, so that we should be comfortable to pour the concrete. Otherwise, we will increase the size of the section. Then displacement, check for deflection, and then IS 13920. To make the structure ductile, we have to follow the IS code 13920. All these conditions should be satisfied. 10 to 12 conditions are there. For each and every element, we are satisfying the conditions. If we fail, then we go on increasing the size to satisfy this condition. Ductility is nothing but you must be using two-wheeler, four-wheeler, then fuel pump is there, fuel indicator is there, tank full, tank half, then reserve, going to empty. That means that reserve value, this ductility is that same. That means if we don't provide that reserve indicator on your vehicle, as soon as the fuel is emptied, it will stop wherever you are. That means you won't get any indication that fuel is going to be finished and you should refill it. Similar way, ductile is so that during earthquake or any failure, it gives the warning that the structure is going to fail, so that the persons who are staying in the building or the premises, they should be evacuated and brought to the safety before the structure should fail. So ductility is the main condition to be followed to make the structure safe for the human lives. Now last is the bill of quantity, then weight of the steel, number of bars, dia of bars, weight, anchor steel bar, and then the results. Again, the tabular format results like slabs, Similar way, the drawing format, the values are available. For the particular floor, that means we have selected terrace for all the beams, 43 beams. At the time of execution, user require or builder require all the data in the tabular format. That means how these results arrive, you can go through the calculation. Similar way for the column. Load I have shown you. Now the calculation. Pink color, separate color for column, same procedure, analysis, design, check, bill of quantity, results. Column data, how load is transferred from the beams, assuming the section, analyzing shear force, bending moment, axial, uniaxial, biaxial, slenderness, and reinforcement, checking, BOQ. What I want to show you, as we have selected C13, that means load from B13 to B14 and B34 and B35, right? B13, 14, 34. Our structure should be stable for the earthquake. So strong column, weak beam. By keeping that in mind, we have to see the width of the beam, which will come on the particular column. The minimum beam width is 230 mm. By reiteration method, how the load is values are transferred, we are assuming minimum section 200 by 200. But as per the clause, strong column, weak beam, we have increased the size. We assume 230 mm. Instead of 200 by 200, we made it 230 by 200. So that column should be strong. And for that, we are assuming 0.7% of the steel. IS code says it should not be less than 0.8%. But for calculation purpose, we are assuming 0.7, and we will see how much we are going to provide so that the structure should be stable as well as economical. As we assume the sectional size, then we have to design by number of formulas, number of procedures. Everything is defined. Then lateral dimension also to be satisfied as per the IS 13920. Minimum dia, maximum dia, stirrups, everything is taken care. Then ideal axial strength, whether actually loaded, load conditions. PU chart, case 1, case 2, case 3, stiffness. Detailed calculation is shown. Movement calculation, 3D movement, slenderness detailing, short column, long column. Column is safe. Movement as per the formulas. Nothing hypothetical, nothing whimsical. As per the clause, page number, and as per the formula, calculation, then concrete quantity, and the steel weight. Again, 13920, number of clauses to be satisfied, and according to that, size is defined. We assumed first 200 by 200, then it came to 240 by 240 because we have selected this column C13 as a square. Hence, its size is increased. Whichever is the maximum size, that is increased. We have got all the results. Close. Now the steel drying. Number of bars. This hook, anchor hook, it should be 135 degrees. Previously, we used to provide 90 degree, but after Bhuj earthquake, it was decided by the highest code authority, it should be 135, and it will make the stable column during the earthquake. This should be noted for the beam also and for the column also. Instead of 90-degree loop, we should provide a 135 degree. By providing 135, the structure will be safe. We have covered slab, beam, column. Now, last is the steel design. This is the particular floor which we have selected, floor 4. This is the groupism. This feature, that means similar columns of the similar size, number of bars or percentage of steel. 1.13. We have assumed 0.7 but provided 1.13, and IS code says it should not be less than 0.8 and it should not be more than 0.6%. But we are very near to 0.8, that is 1.13. In two groups, all these columns are covered, 240 by 200, 240 by 240. These are the rectangular columns, and these are the group 2 are the square columns, group 1 are the rectangular columns. Similar way, for the individual column also, full data is available, results, and 3 formats we have provided. As per your convenience, you can use while executing the project. That means groupism also possible, and you can print it in PDF format. Save it, and you can share with the site executors also. Cancel. Now it will be closed. Right? Now we are coming to the footing. Similar. Same menu. Nothing to remember. No specific menu to search on the dashboard. Just you click on the element. What you want to see, that is available. Calculation. Procedure. Footing data. How the reiteration works, that I want to show you. We are assuming the section size 300. This counter loop starts. It will check all the basic requirements. It failed. Hence, we have increased to the by 100 mm size. Instead of 300, we made it 400. Again, it failed. It's saved. That means D provided 500 is okay. And accordingly, it is designed. Number of bars and all. Then these are tabular results. You have the navigation also. Steel drawing, plan, sectional elevation. For full fitting, all the footings, that means 23 results, 26, sorry, available. We have covered gravity loads. That means for each and every element. Now we are coming to the earthquake. walls. At the first floor, internal walls and external walls, different colors. At ground floor, no walls, open to parking. For terrace, only parapet wall, internal walls not provided. Shear force and bending moment diagram. All these sections, shear force and bending moment diagram is available in x-axis direction and y direction. Shear force. X direction. Earthquake. This is the center of mass and center of rigidity. As our structure is symmetrical on both the axes, x-axis and y-y. While designing, make it a point so that the center of mass and center of rigidity should be near to each other to avoid the torsion. For each and every floor, we got this center of mass and center of rigidity and this eccentricity also in the graphic format. Then torsion. Then drift. How the structure sway during the lateral loads. This is the animation for better understanding how the structure is going to behave during the earthquake. And these are the lateral load values. Then drift. This is the drift values of this particular structure and as per the IS code, permissible values. For X direction, for the Y direction, similar way displacement in X direction, displacement in Y direction, and lateral shear, lateral forces, and this is the shear force, X, the shear force Y. All these will be torsion. Now the calculation. This full calculation is available. For the full structure, it calculates the shear force, bending moment, lateral force, stiffness, rigidity, drift, whether structure is stable or not. It's the real-time calculation. Till that time, we can have a bill of quantities also. Bill of quantities. Earthquake. It took 2 to 3 minutes to calculate. Again, this procedure, it's very lengthy procedure. If the participants are interested, I can explain it. Otherwise, it is visible and you can slab loads, beam loads. Yeah. This is the procedure. Load from slab beam column, seismicity, zone factor, response factor, importance, soil spectra, line size, aspect ratio, solution. Static analysis. Seismic weight, expression spectrum, design is seismic base shear, lateral force and shear force, nothing but VB. Center of mass, center of stiffness, design eccentricity, which I have shown you in the graphic format. Dynamic analysis, multi-degree of freedom, mass matrix, stiffness matrix, Higgins equation, natural frequency, natural time period, number of modes, load participation factor, up to 90% we have to assume as per the IS code. Then three methods, absolute sum method, square root of sum of squares, complete quadratic combination. Again, what IS code says, we should compare with the static analysis, and these values should be matched with the static analysis. So we have to jack up the dynamic shear values to the static shear. Next is the torsion, rotational stiffness, shear and moment, and last ultimately is the stability, drift and displacement. Whether a structure is non-sway or sway. If it is non-sway, then we have to increase the element size, increase the orientate the column and sizes, and provide the 25 load combination. But if it is safe, non-sway, then it is okay. If it is sway, then we have to increase the sizes. Sorry, I made a mistake. This is the project data, which I have already shown you. As per these loads, earthquake detail calculation, IS code says if SILL is up to and including 3, that means less than 3, we have to assume 25% of imposed load. And if it is above 3, then we have to assume 50%. In our case, it is 1.5, so we are assuming 25%. Here it is, we are assuming the EQSIL 0.25%. Detailed calculation is there. Earthquake is big engineering, which cannot be explained in a short duration, but we have provided the detailed calculation of each and everything, that how the structure should be checked and found made stable. These are the values, calculation, slab weight, then beam weight, then column weight, and total. That means total weight of this building is 10,794 kilonewtons, 10,794 kilonewtons, and height of the building is 13.85 meters. And for this purpose, our values now to be checked as per the earthquake analysis. Map I have already shown you. Our is Hyderabad, zone 2. Hyderabad zone 2, point 1. Now, natural period for equivalent static method, it is minimum 2.5, and for dynamic response spectrum method, it's 1. That means for two different procedure, two different values to be obtained from this graph as per the IS code. and the soil conditions, whether it is rock or hard rock, medium or soft soil. As we have considered the rock, that means as per the clause 1, we have to calculate the values. Rock, hard, this dark line. We are providing all this literature which we have to follow as per the IS code. This is the formula. We have to calculate the acceleration spectrum. And these are the values which we require for the calculation purpose by all these data given by the IS code. As we have selected the residential building, so our importance factor is 1. For school, hospitals, it is 1.5, and for other business continuity, it's 1.2. We have calculated seismic zone 2, seismic factor is 0.1. According to that 0.1, acceleration is calculated. It comes to the 3%. That means whatever the weight of the structure of that 3% will act as a seismic shear, base shear. So total weight of the structure is directly proportional to the lateral loads. By designing the structure, one should keep it in mind that the structure should be light as possible. For the same similar way, for the y direction also, we have calculated the base shear. These are the lateral loads, 4 to ground lateral loads. This is the center of mass calculation, which I have shown in the graphic format. Then center of rigidity, I have shown you the actual graph. This is for the reference as per the IS code. The stiffness calculation. This is the table, center of mass and center of stiffness. The static analysis is over up to here. Now it starts the dynamic analysis by response spectrum. This is the in-house developed matrices software. Generally, all the softwares use the particular design software for calculation purpose. For that, we have to pay the royalty, as we are providing free for the education purpose. So we have developed in-house this matrices software, and we are calculating the eigen factor and as per the eigen equation. Again, the formulas. This is the tedious procedure, which is useful for the postgraduate and PhD students, but for undergraduate also, this is the helping tool to guide them and understand how the earthquake analysis to be carried out. We have calculated the natural time period for these 5 modes. All these values in the graphic format: 6.135, 12.5, 26 for second mode, for third mode. These are the dynamic: 5.91, minus 2.4, mode 5, 6.25, minus 3.75. Natural time period we have calculated. We have to found the lowest frequency, and frequency should differ 10%, means well separated. For all the 5 modes, we have calculated the total weight, percentage of total weight, which affects during the earthquake. What the IS code says, up to 90%. That means for mode 1 and mode 2, if we make the combination, it is more than 90%. That means we have to consider only these 2 modes and rest of the modes should be ignored while further analysis. Number of modes up to 90% of the total weight is considered for further evaluation. And again, for the dynamic analysis, we have to calculate the SAG. And as per the SAG, we are calculating the acceleration share. As per these values, we are calculating absolute sum of method, then SRSS method, lateral force and shear force, and third is the CQC method. Again, the matrix is very difficult to understand at first glance. It takes time, but we are providing you the full detailed calculation. You can educate yourself. Combined shear force, combined lateral force. Till now, we have calculated the lateral force and shear force by 4 methods. Under static analysis, the equivalent static method, and under dynamic analysis, these 3 methods. What IS code says, we should mesh these values. By static analysis, we got 324.3 kilonewtons, and for dynamic, we are getting 58, 43, and 43.7. So what we are doing, we are increasing that ratio. We are jack up the values. That means 324 divided by 435, we got the 7.46 multiplication factor, and we got the values. That means with the scaling up, we got these new values, and before scaling up, values were displayed. Now, as per these scaling values, we are calculating the drift and displacement to check the stability. And for that, we require the torsion and eccentricity should be calculated. Again, as per this formula, lengthy procedure to be followed to calculate. Just have a overlook. Provided in the tabular format for better understanding. Now, this is the drift calculation. Again, simple formula, but procedure is repetition. For each and every floor, drift is calculated and tabulated floor-wise. Drift, lateral force, drift, floor displacement, drift ratio. With the scaling up, that means when the lateral force is 324, and this is the without scaling up, when the lateral force is 43. In both the cases, for reference purpose, we display. Now, ultimately comes the stability. Again, as per this formula, we have to see whether the structure is stable or not. Now, by 3 methods, we are taking it, whether the structure is stable or not. One is by equivalent static method, in which we are taking the axial load, that means ultimate load 1.5 times 18,463. And for this dynamic analysis, we are considering only 10,000. That means less than 1.5 times. With the scaling up also, our structure is non-sway, and without scaling also, our structure is non-sway. Hence, a stable structure is provided. Whatever the data we have entered, they are satisfying all the conditions. As we did for the XX direction, similar procedure for the YY direction. Again, the repetition, dynamic analysis. We take these mode shapes, mode 1, mode 2, values. We are coming to the In this case also, 2 moles. That means our structure is nearer to the safety. Again, 90% ratio. For the methods, Jacob 7.5 times, 324. Drift and byward direction. Each and every beam column's stiffness to be calculated. Then torsion and everything to be calculated. We come to the drift calculation. Drift values without scaling up, with scaling up. Both are available. Then stability. All the 3 procedures. In byward direction also, our structure is non-sway, hence it is safe. This menu is helpful so that you can directly go to that particular table. Stability. Even you can print this full report. Print command. It will be saved in the PDF format and you can share with anyone for verification and checking purpose. So 91 pages of this one building of G+3. Everything is printed and calculated. We have covered 4 points. Now we have to, this PDF format is ready. Right? We will cancel it. Bill of quantity. Our is the last. Bill of quantity for the steel, grade wise, module wise, dia wise. Yes, we got it. Project name, steel weight, date. Steel in the slab, beam, column, footing, floor wise, then dia wise, then grade wise. Total, similar way for beam, for column, for footing. For execution purpose, we require bore wise for footing so that builder or contractor can place the order of this steel for this ground floor, for first floor, second, third, fourth. If we check the total of both the tables, 13,806 kgs. 13,806 kgs. That is, this is 0.9, that is 100 gram difference only. That is round off. Similar way, we can calculate cement. Floor wise, grade wise, module wise, slab, beam, column, footing, then as per the floor. We are providing in both the format, one in cubic meters and one in the bags. Cubic meters and bags, whichever is 156.8 cubic meters and 20 grade 8.2, 1266 bags. You can export in Excel. You can edit it, whatever you want, you have the choice. We have covered all the topics, and IS code is also available. 45618931390 for your reference purpose on your click of the button. Log off. I have covered all these aspects, features, and benefits. If you have any query or any difficulty, you can reach me on my WhatsApp number or email ID, whichever is convenient to you. Mr. Rajkumar, from my side, I have completed the demo, and thank you for arranging the webinar, and thank you participants for patiently attending this webinar. If you have any query or question, I am open to that. Thank you.
Thank you very much for your valuable session, sir. Let's open this platform for questions. Dear audience, you can unmute yourself and you can ask the questions.
Good evening, sir. So this is Vivek, currently working in GR Infra Projects design team.
Pardon?
Hello?
Yes.
Yes. Sir, actually, the whole theme and idea of the software is like it is user friendly and it makes design also easier. So I have some questions. Like
Yeah.
here, the software I think mostly designed for if founding levels are same for same, no, sir. Like if we have different founding levels,
No,
do we have any option?
No, at present we have provided the isolated footing, but in future we are going for the additional options. We are working on it.
Okay, sir.
Yeah, it's
Sir,
possible.
and
Nothing difficult. Rough foundation,
yes.
joint foundation, we are open for that. Yeah.
Okay. Sir, and we haven't considered wind loads, no, sir, here.
Yeah, at present we are not considering because wind load is not that much difficult.
Yes, sir. Yes, sir.
What I observed, the structural failure in our country, particular in our India, they are failed due to earthquake only. And as per IS code, we have 1893. I have put the most efforts to make this earthquake resistant. If
Yes,
our structure is resistant for the earthquake, that is roughly, you have seen 3% to 4% the total weight. What I observed from my experience, for wind load, it comes around 1 to 2%. That's all, not more than that. That automatically this our structure is safe during the wind condition also. But I am open to it. We can compare this with the other softwares, whether our designed section elements are safe for wind or not. I am open to that. I am really thankful to you if you provide me the comparison whether our section or our structure is safe in the wind conditions or not.
yes, sir.
Yeah.
Sir, and here we have considered only square columns, no, sir. Like we haven't considered any circular sections.
Yeah, circular, these are this aesthetical and for architectural point of view, right?
Yes, sir. Yes, sir.
There we can provide that also. What I have
Okay.
observed, wherever the square column is there, we have to provide more, that means 4 bars, right?
Yes, sir.
If it is the circular column, then
6.
we have to provide 6 bars.
Yes, sir.
That means for the minimum section, we are providing 50% more steel.
Yes, sir.
Am I right?
Yeah, yeah,
Correct?
sir.
My,
Yes, sir.
my principle or my first aim is what? The structure should be economical as well as
Yes,
this.
sir.
By keeping that in my mind, we have kept only square and rectangular columns. But we are open for that. You can provide the square or rectangular or circular. I have provided you the values, shear force and bending moment. I have done the analysis.
Yes,
You
sir.
have the liberty. You can provide.
Okay.
All other softwares, what they are doing, first you have to draw then you have to export that drawing. They do the analysis. After analysis, you export that data for the designing. And after that designing, you export that data again in the new software for detailing, drawing. We are providing all in one. So somewhere we have to compromise, which is not essential for the stability of the structure,
Yes.
right? Yeah.
Yes, sir. Yes. Sir, and what about exposure conditions, sir? Will it considered automatically based on location, or how it will be considered?
Mostly
Like for
it's
cover?
the seismic zone and seismic factor we have to require. And according to
Yes.
that, we are calculating.
Okay, sir.
The similar project, what we are doing, we are providing for number of colleges. Our zone is 2, that means 0.1 seismic factor. Even the same
Yes.
building, if it is comes in the zone 4 or zone 5, then seismic factor is 0.36 or 0.24. Then how it behaves in that particular location? Same building, same data, everything is same, but the location is different. Instead of 3% of this acceleration factor, it goes up to 5 and 6%. That means almost double. Then also, what our structure will do, it will increases the element sizes, sectional sizes according to that loading conditions.
Okay, sir.
Yeah.
Okay, sir. Thank you, sir.
May I know your name?
Sir, Vivek, Konchada Vivek.
You have asked very good questions. Thank you. And I am
Thank you.
eagerly waiting for your comparison with the wind forces.
Sure, sir. Sure.
Thank you.
Thank you. I will contact you through WhatsApp, sir.
Yeah. My WhatsApp number and email is available on my homepage, right?
Yes, sir. I took photo.
Yeah. Thank you.
Thank you. Thank you.
Yes.
And any other questions, you can unmute yourself and you can ask.
Number of users asked about the recorded session. Ask them that is it available in the tutorials. If they go in the tutorial, no, they are available. First, it will serve their purpose. Even you can provide them, that also looks good.
Dear participants, we already posted the speaker's LinkedIn profile over in our chat. You can find it. And also we are posting now mvdot.com.
Then, Mr. Kumar, if there are no questions, shall we conclude?
Hello, Rajkumar sir, are you there? Okay, let me give you the end note. As you know already, this session is getting organized by the construction leaders. Construction Leaders is a influential platform for architecture, engineering, and construction industry professionals. We do regularly conduct the webinars and the workshops, and we have specific interest in bridging the gap between the academics and the industry. As part of that, we are providing workshops on different topics and particularly on building information modeling to the students and the faculties in the colleges. If you have any requirement, then you can always reach out to us or the LinkedIn to Viniti Rajakumar sir or me, Naveen Kumar Nagipoku. We are always here to help you all and to bridge the gap. Thank you for your participation. And I hope to see you all in our next upcoming sessions. Thank you. Thank you very much.
Thank you. Thank you.
Thank you so much, sir.
Thank you.
Yes, sir. Thank you for giving your valuable time. Yeah. I will share the recording, sir, after that one, after editing, sir.
Yeah, and screenshots also. Okay.
Yes, sir, definitely, sir.
Yeah,
Yes.
thank you.